will be the potential of this sphere when the charge is q? So what is rho? Rho is charge per unit volume for this complete sphere. Find electrostatic self-energy. So hello everyone and welcome to LN Overseas. So I'm back with the series that is 45 topics in 45 days. In this series we take 15 topics from each subject summing up to 45, and today we are going to take a topic of physics, and that is self-energy. Self-energy, right? This topic is kind of confusing, right? There is something known as potential energy and there is something known as self-potential energy, right? What it is, let us understand in today's session. So the total work required to assemble the charges on any object will be stored as its potential energy, right? So let us consider a case. We have a sphere, right? And I have some charge at infinity. And I will be bringing that charge slowly, one at a time. One at a time means very small charge. I will be taking it from infinity to this point. Okay. Now let us start. Charge comes. We have another charge. Again, more charge. Charge increases. Then taking another charge. Charge increases. Then taking another charge. Charge increases. Charge increases. Now, as I am taking a new charge from infinity to this point, the already existing charge is creating a resistance. That means I have to do some work in order to take the next charge. And when we'll be talking about every next charge, the previous charge which has been stored in this is going to resist. So that means the charge of this sphere is going to change, right? So the potential energy of this sphere is going to change, or the potential of this sphere is going to change. Getting the point? Yeah. Okay. Let us understand this thing from another angle. So we have this sphere that is charged. This sphere will have its own electric field. Definitely it will. So this will have electric field, this charge will have electric field, this charge will have electric field. Okay, they have their own electric field, but they also get influenced from each other's electric field, isn't it? So if you consider this charge, all rest of the charges are going to create electric field and this will be influenced by it, right? So it is self-interaction. So if I am bringing this and I am doing work, there is some work done against any external force. So that work done will be stored as something, right? So guess in which form it is going to get stored? Absolutely, that is electrostatic energy. It will be stored in the field, in the electric field that is being developed here. Agreed? Yeah. So let us try and calculate how much is this self energy. Okay. Let us consider a thin shell, right, and try to charge it to Q, to charge capital Q. Okay. So initially, suppose this is uncharged and I will be bringing small charge from infinity and I will be keeping here onto this thin shell. So the charge on this shell is going to be increased. So at any instant, suppose the charge is Q. At any instant, suppose the charge is Q. So what will be the potential of this sphere when the charge is Q? You very well know that thing is going to be KQ by R, right? Okay. Now I am bringing a small charge dq from infinity to this point. So there will be a small work done in bringing this small charge dq. How much will be the work done? That thing will be equals to v dq. Agreed? Change in potential energy, final potential energy minus initial potential energy. I am taking it from infinity. So initially infinity, at infinity potential energy is 0, finally v dq. Simple. So this thing will be equals to kq by r dq. Agreed? No rocket science. So this is the work done. The external agent is doing, that will be stored in the form of potential energy, and that is your self potential energy. That means if you are going to integrate this thing from 0 to capital Q, the charge is going from 0 to capital Q. So this thing will turn out to be kq squared by 2 by r from 0 to q, and this, my friends, is the self energy. Yeah, definitely. So this thing is half kq squared by r, right? Do not worry about this r, right? My bad, if this is capital R, so this thing will be also capital R. No problem in that. That is the constant, right? Okay. So this is the self energy stored in the thin uniform shell, uniformly charged thin shell. Okay, that is self energy. Now you can realize this thing in one more form as well. So the energy is being stored in electric field, right? So what is electric field energy? That is half epsilon naught E squared into V, right? So inside there could be, I am not saying there is some energy, inside there could be some energy, and outside as well there could be some energy. So U net will be equal to U inside plus U outside. Now if this thing is a variable, then of course you have to evaluate the integral to solve this thing. Yeah. So inside, of course, the electric field is 0, so this thing will be 0 for this case only. You can evaluate U outside, substitute the value of electric field outside, calculate U outside, right, and evaluate this integral, and this integral is going to go from this point R to infinity. Electric field exists from this point to infinite. So integrate this thing from R to infinity and you will get the same result. Trust me on that. So this is one way to get to it, and this is the simplest way, right? Charging that sphere. Let us change the sphere. Uniformly charged non-conducting sphere. So we have a sphere, right, and it is uniformly charged, and suppose I will be charging it to Q and radius is R. Of course I will be bringing that charge and I will be keeping that charge onto this sphere, but it is slowly going to increase, right? So I can model it out. That does not happen in real life. In order to mathematically model it, I will be using a trick. What's that trick? First is you can definitely calculate U net is equals to U inside plus U outside. Now in this case, inside electric field is non-zero, so you have to evaluate this thing as well as this thing as well, right? You can proceed like this, or what you can do, you can consider this sphere and try to charge it, right? This is the sphere, this is the charge, keep on bringing the charge. So suppose this is the initial charge at any point. What is going to happen when I am going to bring the charge? Comes charge, increases, 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 increases. What happened? I considered that there is a small sphere that is being formed. Initially, the radius of that sphere is 0, and that sphere is growing bigger gradually as the charge is coming. Getting the point? So initially what I can do is to take this much sphere, right? Suppose I have brought this much of charge so that it is distributed onto this much part only. In reality, it doesn't exist. This is a mathematical model. Okay. Okay. Then what? Then first let us calculate how much. Suppose rho is the density, right? The charge density, the volume charge density of this sphere. So what will be the charge inside? That will be equal to rho times volume inside. Agreed? So what is rho? Rho is charge per unit volume for this complete sphere. So that is Q over 4 by 3 pi r cubed, capital R cubed. And now suppose the radius of the instantaneous radius of the sphere is r. Okay. So this thing is 4 by 3 pi small r cubed. This gets cancelled definitely. So this thing is Q r cubed over capital R cubed. This is the charge. Okay, nice and easy. Now I am bringing the charge, so what is going to happen? The radius of this sphere is going to increase. How much charge I brought? That is dq, right? And suppose the radius that is increased is dr. Yeah, not the first time you are doing this, right? So now, how much is the charge? You can either calculate charge on this shell, or my way, just differentiate this thing. Differentiate this thing, dq is equals to q over r cubed, that is a constant. Differentiate this thing will be 3r squared dr. Yeah. So what will be the potential of this sphere? Potential of this sphere will be equals to k q, right, by small r, right, the inner sphere. Okay, what will be the work done? That is v into dq, right? So this is small work done, and when we are going to integrate it, we are going to get, yes, self energy. Yeah. So this thing will be equals to kq over r dq. What is q? That is q r cubed over r cubed. And what is dq? dq will remain as it is, right? This thing as it is. So this thing will be q over r cubed times 3r squared dr. Yeah, agree? Okay. Nice. Now what? U self will be equals to integral of, now we have converted this integral into r, and r is going to vary from 0 to capital R. Very nice. So 0 to capital R, k q squared, right, over r cubed times r to the power 6, right, r cubed plus r cubed, r 3 plus 3 times there is 3 that comes outside r to the power 5 dr. Yeah, definitely. This thing, this complete thing is constant, comes outside. What will be the integral of r to the power 5 dr? You very well know that thing. That thing will be equals to r to the power 6 by r, right? So this is k q square by r, and there is one more r, right? There is one more r here. Okay. So this thing will be by r. So this will be equals to 3kq squared by r to the power 6 integral of r to the power 4 dr. What will be this integral? You very well know that thing. That is 3 kq square r to the power 5 by 5 times r to the power 6. This gets cancelled, right? And finally, the self energy, if you open up this k 1 over 4 pi epsilon naught. So this thing will be equal to 3 by 4 times 5 is 20 pi epsilon naught q square by r. This is the self energy for the solid sphere, non-conducting solid sphere. You are going to get the same result using the electric field energy as well. Okay? No rocket science. Alright, let us take a question. If the value of charge density of a dielectric sphere with cavity as shown in the figure is rho, find electrostatic self energy. Okay, so this is a sphere with a cavity. Outer radius 2r, inner radius r. So we have the integral limits. Okay, can we do the same exact thing here? Yeah, we can. Let us try. So first of all, what we have to do? Consider a sphere. Consider a sphere. Done. Then increase the radius of that sphere. This is r. This is dr. Charge that is increasing this sphere is dq. Okay. So first of all, what is charge? Charge is rho times the volume that is inside. How much is the volume inside? That is 4 by 3 pi r cubed, small r cubed minus capital R cubed. Check. Volume that is inside. Yeah, definitely. Okay, what will be dq? Differentiate this thing. So this will be 4 rho pi by 3. If I differentiate this, this will be 3 r squared and rest will be 0. Right? So this thing will be equals to 4 pi rho r squared dr. No rocket science. What will be the potential energy? Potential energy is k q by r. Yeah. Substitute. Work done will be equals to V dq. So this is kq by r dq. Right? Substitute q and dq. This is k into 4 pi by 3 into rho r cubed minus r cubed. There is one r already sitting here. times dq, 4 pi rho r square dr, right? No rocket science. Okay, from here what we have, 16 pi squared, right? 16 pi squared over, I am opening k, 4 pi epsilon naught, 1 by 4 pi epsilon naught by 3, this is gone, this is gone, this is gone, times rho squared, rho, there is rho here, rho is here, inside 1 r gets cancelled, right? So this thing will be equal to r to the power 4 minus r cubed into r dr. Check. 16 pi squared rho squared by 3 k, I have opened up k, I have multiplied r inside, so this is r to the power 4 minus r cubed into r dr. No rocket science. So this is dw. What will be self energy? The work done will be stored as self energy. So this thing will be equals to integral of this thing, right? Let me write the constant stuff outside. So let me cancel it out. This is 4, this gets cancelled. So this is 4 pi by 3 epsilon naught rho squared and integral of r to the power 4 minus r cubed into r dr, and the integral will be from r to r. Evaluate the integral. So u self will be equals to 4 pi rho squared over 3 epsilon naught. This is r to the power of 5 by 5 minus, this will be r to the power 2, right? R cubed into r to the power 2 by 2, and limit varies from r to r. So self energy will be equals to 4 pi rho squared over 3 epsilon naught. Substitute the values. This will be 8 r, not 8, this is 2, right? So this is 32 r to the power 5 minus r to the power 5 over 5 minus, this is 4 r to the power 5 minus r to the power 5 by 2, right? You can easily evaluate that thing. What was it? 32 r to the power 5 minus r to the power 5. Let me write it here only. So this is 31 r to the power 5. This is 3 r to the power 5. So 31 into 2, 64, and this is 15. 64 minus 15, it will be 62 minus 15, it will be 7 and 47, right? 47. So this thing will be equals to 47 r to the power 5 by and 10. right? And whatever was there, whatever was already there, what was already there, 4 pi rho square over 3 epsilon naught. 4 pi rho square over 3 epsilon naught, right? You can easily evaluate this thing. This is 5, this is 2, this is 94 pi rho squared r to the power 5 over 15 epsilon naught. Looks ugly, but it is what it is. You can use the same thing as well. You can calculate the electrostatic energy for inside, outside, add them together and you can get the result. However you want. Alright. And if they ask you that what is the net potential energy of a system which have a sphere and a point charge, sphere and the point charge, what is the net energy, then you need to give the answer of the energy needed to assemble the charges. So this will be self energy of this sphere. It could be thin sphere, it could be conducting sphere, and this charge, the energy of the interaction between the sphere and the charge, right, that is kq by r, right, kq, if this is capital Q, kq by r. You just have to add them together and you will have your answer. That's how it is. So thank you, that was it for today. I hope you have enjoyed this session with me. So if you have any queries, any question, any doubts, you can drop them down in the comment box. And if you want to follow the playlist, the link is available in the description box. So bye bye, have a nice day ahead.